Hi Sunshines! So we're going to start our 3D figures chapter, which is mostly about volume. Before you can get started calculating volumes though, you need to know what figures you're working with. Otherwise, you're not going to be able to choose the correct formula. We're going to start off with prisms and cylinders, which are basically the same shape. Prisms and cylinders each have two congruent bases and then a wall that connects them. So those bases are the same shape. The two bases are the same shape. They're congruent and they're parallel to each other. They're lined up. And then with a regular prism, it's translated perpendicularly to the other base. There's special types of prisms called oblique prisms and twisted prisms where the transformation is a little bit different. It still has to be parallel, but it could have moved around a little bit. We're not really going to focus on those. Mostly you deal with the regular ones. And then it has a wall that's basically just a giant rectangle wrapped around your shape. So for a cylinder, your base is a circle. For a prism, your base is any kind of polygon. So this one is an octagonal prism because it has an octagon for its base. This is a triangular prism. This is a rhombic prism because I have a rhombus for my base. Trapezoidal prism, I have a whole little connection for my daughter's little shape sorter. Now with that lateral surface that's wrapped around, for a circle, it's just one curve, one big curve, so it unwraps into a single big rectangle. With prisms, because you have polygons all have straight sides and angles, each one of those angles divides your wall into a little segment. So for an octagon with 8 sides, I actually get 8 little tiny rectangles that my paper is creased into. Mostly we deal with regular polygon bases. They're a little easier to work with, but you'll see some of every type. With triangles especially, you'll see a lot of very irregular triangles. With other polygons, usually it's more the regular bases. So when you're naming it, it's again base shape and then the word prism, or for when we get up to pyramids, it's the same idea, the same system. Cylinders, you just call them a cylinder because everybody already knows that means the base is a circle. Unless you're talking about weird cylinders, you can have elliptical cylinders where you have an ellipse instead of a circle. That's where you have the circle kind of stretched out. We're again not really going to focus on those. We're mostly going to focus on just the regular circle-based cylinders. So we just call those cylinders. Like I said, pyramids work the same way. You name it based on the base shape. So you can have a cone, has a circle as the base. Or you can have, this here is a square pyramid, like the pyramids of Giza. Those are square pyramids as well. So I have a square as my base, and then my lateral surface is a bunch of little triangles. So if it's a square, that means I've got 4 sides. So I've got 4 triangles that come up and meet at a point at the top. You can also have triangular pyramids, like these little dice. So you have a square, and then these are triangular pyramids. So you have a triangle, and then each edge is another triangle. These are a special one called tetrahedrons, where all of the triangles are congruent. So they are triangular pyramids, but they're also polyhedrons, which I'll talk about in just a minute. Identifying your base shape when you're dealing with prisms and pyramids, identifying your base shape correctly is super important. If you have the wrong base, if you pick the wrong side to be your base, you're not going to be able to calculate the volume correctly. So if I tell you to find the volume of this square pyramid, but I lay it on its side, and then you look at it and you're like, I don't know what that shape is, you have to remember, you have to have that skill to be able to turn it on its side. Same with prisms. You see it more often with prisms, especially triangular prisms. All the time you'll see triangular prisms on their side. You have to still be able to recognize that they're triangular prisms and that this is the base, even though it's the front of it looking at it or the side of it looking at it. So like this looks like, you know, a tent. If you go camping, this is what a tent looks like. If you're going to try and find the volume of the tent, that's a triangular prism, even though your bases happen to be going vertically instead of horizontally. The last thing is polyhedrons and spheres. We don't really talk about polyhedrons in the volume chapter too much, but they get a special mention for being the polygon version of a sphere. So pyramids and cones use the same formula. Prisms and cylinders use the same formula. Polyhedrons and spheres, you actually can derive there's a lot of ways of deriving the volume of a sphere. You can do it with calculus, but you can also do it as an approximation of polyhedrons, where you just make it infinitely many little tiny surfaces, because the more, if you think about video game design and graphic design, the more surfaces you add, the more like a curve it looks, but really you're usually not dealing with a true curve. Computerized surfaces are just dealing with little tiny polygons. And so the more polygons you have, the better it looks. So I think everybody knows what a sphere looks like. I got my daughter's little ball pit balls. And then polyhedrons are like these little guys. Here, my little gaming dice collection. So these are all polyhedrons. This is a D20. That means it's a 20-sided. And this is a D8, so it's 8-sided, so it's an octahedron. So we're not really going to deal too much with polyhedrons, but I wanted you to be familiar with the fact that they exist, and they're things that go with spheres.